Just now we have seen that as the speed of rotation of the earth increases, the acceleration due to gravity on the earth decreases, and when the speed becomes 1.25 into 10 to the power of minus 3 radian per second, the acceleration due to gravity at the equator becomes 0, the weights of bodies present at the equator become 0, they all fly off tangentially. But the bodies at other places, they still remain on the earth with their weight, of course, very less. Now if you want that even those bodies should lose their weight, then we have to further increase the angular velocity of the earth. Let us see for what angular velocity bodies at any latitude lose their weight, or g at that latitude becomes 0. For that one, let us consider this equation g phi is equal to g minus r omega square. Now here one doubt you will get, what is this g? This is the acceleration due to gravity at the poles, because we are considering that the earth is perfectly spherical. If it is not rotating, the acceleration due to gravity at the pole at any other place also will be same. This is the g when earth is not at all rotating. Since rotation has no effect at the poles, we also call it is the acceleration due to gravity at the poles. Suppose it is asked in this formula g phi is equal to g minus r omega square cos square phi. G stands for acceleration due to gravity at number 1 at the equator, number 2 at the poles, number 3 at a latitude 45 degrees. Then you will be confused. Instead of taking extreme sides, you will go for 45 degrees. Or some may think that it is for the equator. The real answer, the correct answer is it is the acceleration due to gravity at the poles, or it is the acceleration due to gravity at any place if the earth is perfectly spherical and not rotating. Now we want to find for what angular velocity of the earth the acceleration due to gravity at any place of latitude phi becomes 0. Let us write the general formula for acceleration due to gravity. G phi is equal to g minus r omega square cos square phi. We want to find for what omega g phi is becoming 0. Let us substitute g phi is equal to 0 here. 0 is equal to g minus r omega square cos square phi, or r omega square cos square phi is equal to g. Omega square is equal to 1 by cos square phi g by r. Omega is equal to 1 by cos phi under root g by r. Now, for what angular velocity the acceleration due to gravity or the apparent weight of a body becomes 0. First, let us consider a point at the equator. Its latitude is 0. We know that it is g by r under root g by r. We know the value of under root g by r is 1.25 into 10 to the power of minus 3 radian per second. Now we are going to place of latitude 30 degrees. Then in this formula, we have to write 30 degrees. So 1 by cos 30 under root g by r. Cos 30 is root 3 by 2. So it will become 2 by root 3 under root g by r. So 2 by root 3 into 1.25 into 10 to the power of minus 3. You simplify it. Then for latitude 45 degrees, it will be 1 by cos 45 under root g by r. Cos 45 is 1 by root 2. So 1 by cos 45 is root 2. Root 2 times under root g by r. That means root 2 times of this value. Then if you consider a point at latitude 60 degrees, it will be 1 by cos 60 under root g by r. Cos 60 is half, 1 by cos 60 is 2. So it will be 2 times under root g by r. This was asked once in the earlier examination, NEET examination. Okay, 2 times of this means it will be 2.5 into 10 to the power of minus 3 radian per second. Then we are going to the poles. Theta is 9, phi is 90 degrees. 1 by cos 90 is infinity. That means g will not become 0 for any velocity, any angular velocity of the earth. Whether that rotates or not, whatever g is there at the poles, it will remain same. The rotation of the earth has no effect at the poles. It has got maximum effect at the equator. As we move from the equator to the poles, the effect of rotation decreases. That means the decrease in g decreases, the remaining g increases. After this, we'll consider altitude effect.